In this video we're going to review the process of plotting points on the Cartesian plane. And yes, I do want you to write all of the information on this page down, mostly because it is enriching for your soul and it's interesting information. So we have this guy over here, René Descartes. And René Descartes, or as it looks Descartes, is a pretty interesting fellow. In my opinion, he's sort of like the first person to come along and with a learning disability. You see, prior to René's existence, most everybody talked about geometry in terms of like take a segment of a certain length. There was no ruler, there was no number system. René is the guy who brings us along. So let's take a look. He's best known, right? And he's best known. Philosophical statement is the "I think, therefore I am," and here's the Latin version, and I believe that's "cogito ergo sum." I apologize if that's not how you pronounce the G. And René is both a philosopher, and mainly that's what he was. He was a philosopher and a mathematician. So early on, a lot of these guys, Socrates and Plato and Aristotle, all right, who, by the way, these guys are all Plato. These guys are all each other's teacher. Socrates taught Plato, who taught Aristotle, and so on and so forth. So René, they're all huge mathematicians, and so he is a philosopher and a mathematician. Philosopher first, mathematics is part of his philosophy. His Latinized name is Renatus Cartesius, hence the Cartesian plane. So when you say the plane, the Cartesian plane, you're actually talking about somebody's surname. So René, his Cartesian coordinate system allows us to, it says reference. This is reference a point in space as a set of numbers and allows algebraic equations to be expressed as geometric shapes in a two-dimensional coordinate system. So what does that mean? It means, first of all, that it allows us to reference a point in space. It means that we can actually locate this piece in terms of some XY coordinate system. And the other thing is it allows us to express geometric shapes on also a two-dimensional system. So in geometry you'll learn about how algebra sort of takes off in a geometric form. And the geometry that you learn about is coordinate geometry, right? You're going to study coordinate geometry. And that coordinate geometry would not be around without René Descartes. Now that you have all the background information, let's move on. So what I have here is a question that mimics the first type of questions in your weekly problem set. If we take a look at point S here, point S is at -8, 4. The -8 refers to my x-coordinate and the 4 refers to my y-coordinate. When I refer to my x-coordinate, that's my horizontal axis, my x-axis. So make sure again that you're taking these notes, right? Our x-axis is our horizontal axis. It runs left to right. And the negative numbers are to the left. One of the things I like to say is that left is less. Left is less helps me remember that this way are negative values. Next is my y-axis. My y-axis moves up and down with 0 at the center. As I move up, right, that's good. I think about positive in terms of grades. You know, grades are going up, that's positive, and grades going down, that's negative. That's how I hold on to the y-axis. Silly stuff helps me hold on to that. So right here in our Cartesian plane, we have the x-axis right here, left and right, negative numbers labeled over here, positive numbers labeled over here, positive y-axis here, negative y-axis right here, and right in the center here is our origin, right? That's where we originate. And the last thing you want to get into your notes are these three sets of words here. Ordered pairs. So take Q here, for example. Q is an ordered pair. Why do we call them ordered pairs? Because it comes in the same order. X first, Y second. It's the same order. In fact, it's alphabetical order. Coordinate pairs, right? Again, the word pairs comes into play. Why? Because there's two of them, and they are a pair of coordinates, an x-coordinate and a y-coordinate. We also refer to them as a solution set, but that's more in terms of an algebraic equation term. So we're not going to really focus on the solution set. We're going to call them ordered pairs or coordinate pairs. So let's plot our ordered pairs. Q, what are we going to do? We're going to start off at the origin, and we're going to look at our x-coordinate 0, which tells us which way to move left or right. It's 0, so we don't move left or right. 4 is our y-coordinate, so we're going to move up 4. So I'm going to put a little circle here. I'm going to label that Q, and that's Q. Now, let's run through for R. R has an x-coordinate of -1 and a y-coordinate of 0, so that means we're going to move left to -1 and then move up or down 0. So a little dot there. Here's our R. Take a moment, draw a quick sketch of some graph paper of your own, just a quick sketch, and get some hash marks on like this, and do S, T, and U on your own. Press pause now. Alright, this is what your final sketch should look like. Of course, not as completely polished as this unless you have perfect graph paper, and if you'd want, if you're working with me, you can ask me for some graph paper. If you're on your own, just, a quick sketch, something along the lines of just getting your y-axis, your x-axis, put a couple hash marks right here. Try to stay even, and as long as you're in the general vicinity of where these points are, right, you'll know if you're right or wrong. Okay, so here's another question. All right, we have 5 points. Again, just press pause, plot these 5 points, and then check them against my answers. Press pause. Okay, how'd you do? And again, you can just press pause and take a quick look at this and match them up to your answers. And again, don't use this to copy these answers. Videos, this is about helping you grow, and you can't grow if you're just merely copying answers off the screen. You have to work on your own and then check your work against this. That, my friends, is growth. And that's what Rene Descartes would have enjoyed. Next, what we want to do is take a look at the coordinates and get a rough idea of where they are in terms of quadrants. Now, quadrants, if you recall, are labeled in Roman numerals, and so your quadrant 1 is where everything is positive, positive for x, y coordinates. Quadrant 2, the x-coordinate is moving to the left, so it's negative, and up for the y, so that's negative, positive. For quadrant 3, you move left for x, down for y, so that's negative, negatives. And then for quadrant 4, you're moving to the right for x and down for y, so that's positive, negative. So when I look at W, I notice that W is a negative, negative. It's negative 10, negative 9. So it's 10 left, 9 down. And this is where W is. So you don't necessarily have to plot the point, but you have to recognize that W is in quadrant 3. V also has a negative x value and a negative y value, so that's going to move left and down, putting us in quadrant 3 again. U is positive, positive, so U is in quadrant 1, right? 9, 6, 9 to the left, 6 up. Somewhere U is right around there. T is 2 positive, 7 negative, so that's moving to the right and down. So T is in quadrant 4. And S is negative 6, 8, or left 6, up 8. So S is in quadrant 2. Notice I'm using Roman numerals. Okay, so now let's move on to our next question. And you take a moment to try and denote who's where. So take a minute, draw yourself just a quick Cartesian sketch, and just label all your points on your paper, U, T, S, R, Q, and let's put some colons, and then right next to them, label the quadrants that they're in. Press pause now. Okay, so here's my final answers off on the left side here. Let's just take a moment and check your answers. Press pause while you do that. Okay, and now notice that I've added one more point here. K is at 0, 5. So where is K? K is right here. So what quadrant is that? It's not quadrant 1, it's not quadrant 2. K would be on the y-axis. So sometimes a point isn't necessarily located in a quadrant specifically. It's split between two, so we will just talk about the axis it's on. If we had a point that was right here, we would just say that name. So say it was, oh, I don't know, it was B. Then I would put B colon X axis. And the last point of business of your exercise in this video is to identify where points are. So again, at this point, I don't think I need to go into it very much. Just taking a look at S, we really want to just focus on notation. I want to write S, parentheses, with a comma in between. It was 3 to the left, so that's -3 for your X, and 1 up for Y, so that's -3, 1. And you want to do that for the other 4 points. Press pause and do that now. All right, let's see how you did with identifying points. Here are the solutions. Hopefully you did well. Got 5 more to go, and we're almost done, and then we'll be done. Here's the last question. Again, truly press pause. Take but a few seconds to identify where all the points are, then unpause it and check your answers. All right, and there's our last set of answers. How'd you do? Do you have any more questions, or are you a Cartesian pro? Last thing I'd like for you to write is this wrap-up page, and just make sure that you agree with me that now we can plot points on the Cartesian plane. We can identify quadrants or axes for any given point, and we can identify the coordinates of a given point. All right, onward and upward to the problem set.